Welcome to a video explaining how to solve quadratic word problems where the equation is not given. So let's start by talking about a frame or border type of problem, which says a picture 100 by 50 centimeters will have a border of X all around it. The area of the border is the same as the area of the picture. So total area is twice the area of the picture. Find the border length. So first of all, we're going to draw a rectangle showing the dimensions. Then we'll draw the border of size X width. And so area of a picture is length times width. And if you place the required dimensions in, you get 5,000 centimeters squared. Area of a total is still length times width, but now it's bigger dimensions. So first of all, we'll start with width. Width, as you can see from the picture, is 50 plus x on either side. So that's 2x plus 50 in total. And then length is x plus 100 plus x, which is 2x plus 100 in total. Now, area of the border, it says in the question, is the same thing as the area of a picture, which is 5,000. So the total area is 10,000. And so we can place that in for area of the total. Now, because this equation has only one unknown, we can solve for this unknown. You do not have to look for the vertex in this quadratic because in the question, nowhere does it say to find maximum or largest or minimum or smallest of some sort of quantity. All right, so now we're going to use the same equation we came up with to proceed solving for this. So first step is to expand everything in the two brackets. Then we want to bring everything to one side to have 0 on one side because this is a nonlinear equation because x has an exponent of 2 on it. We cannot isolate for that x because x appears in two spots. What you could do is try to factor this. 4 is common to all of them, so you could pull out 4 as the greatest common factor. And then you could try to do some sort of factoring on this, and you'll notice that all the combinations that you might try, that they will not work. There is a faster way of checking whether something factors or not. It is by looking at something called a discriminant, which is the portion of the quadratic formula under the root b squared minus 4ac. So in this situation, if you were to actually find out that discriminant and do a square root on it, you'll find out that it's not a whole number. And so this is a good clue to know that this thing will not factor. And so you have to use quadratic formula to solve for x. All right, so here is the quadratic formula. So now you could choose to use the a, b, c from this equation if you wanted to, or you could use the a, b, c from this particular equation without that 4. Both of them will work. And when you plug the numbers in, you get two answers. One of the answers turns out to be negative, and x is our border length, which cannot be negative. So therefore, the border here will have to be 14 centimeters. So the second question we're going to discuss is a falling object problem. Here's the question. A rocket is launched from 20 meters high with an initial speed of 120 meters per second. Find the time when the rocket is at 35 meters high and is on its way down. So we're going to use this equation that is always going to be set up in the following way for any type of problem that is being pulled down by gravity. So we'll have h equals negative 4.9 t squared. So negative 4.9 is gravity acceleration cut in half. I will talk about why later on. V represents initial velocity. Velocity is just another name for speed, but with the direction that could be positive or negative. And the c is going to represent the initial height. In our question, we are told the initial speed, so 120 will go beside the t. And we're also told the height from which it was launched, so 20 goes for the initial height. Now in this equation, the two variables that are left, h is going to be height in meters and t is going to be time in seconds. Now, The reason why this equation works will be actually developed in AP Calculus. It stems from the constant of acceleration of gravity. So we know that gravity is 9.8 on Earth. So there's a process called integration. So if you were to integrate that, you would get velocity. If you integrate that, you would get height. And this is the reason why the equation will work the way it is. Right now, you don't know anything about integration, so just wait until you get to calculus class. So we're going to take the original equation we've developed, and we're going to plug in 35 meters for the height, because we are asked to find time when the rocket reached that height. We're going to have to bring the 35 over to the other side, because this is a quadratic equation, and we cannot isolate for t if t appears in two spots and they're not like terms. So we'll have to have 0 on one side. And you'll notice here that, again, we have only one unknown, so we can solve for this unknown. You will not have to be completing the square to find the vertex here, because the question does not say find the maximum height of the rocket. So we're going to solve for this unknown t by using the quadratic formula. And you can see the values for a, b, c taken from the coefficients. As we plug the numbers into the quadratic formula, you get values for the x-intercepts, or I should say t-intercepts here, close to 0, and another one close to 24 seconds. Now, I would like to discuss the differences between the related equations 0 that I've plotted on this graph over here. The related equation is the one that has 0 on one side of the equation. So you could see how this equation has at the y-intercept spot is -15, which is shown on this graph here. Now, if I were to plot the original equation has a 20 y-intercept, so there is a shift upwards of 35 units for this other graph. So the main thing that you want to take away from this is that the zeros of the related equation, if they were to be plotted at on the original height graph, they will be actually, in fact, where exactly the height is at 35 meters high. And so therefore we can actually answer this question that the rocket was at height 35 and on its way down at around 24 seconds.